Hi, we are recording Chapter 4, Section 6, Congruence in Right Triangles. So, don't forget to put the date up at the top because I forgot to leave you a line, so don't forget to add that in. All right, so first thing we have are the parts of a right triangle, and what you need to know are the sides that include the right angle are called the legs. The side opposite the right angle is called the hypotenuse, and the hypotenuse, except it should only have one U in it, the hypotenuse is the longest side of the right triangle. Right underneath that on the first page, we have the hypotenuse leg theorem, which is our fifth way to prove triangles congruent. Now, this one's special. It can only be used with a right triangle. And what it says is, again, if the hypotenuse and leg of one triangle are congruent to the hypotenuse and corresponding leg of a second triangle, right triangle, pardon me, then the two right triangles are congruent. And for this right triangle, we have triangle BCD is congruent to triangle POM. Now, at the bottom of the page, this is also important. You have 3 reasons for things you need to include in a proof to show that two triangles are congruent by HL. You want to show that the two triangles are right triangles, and then of course you need congruent hypotenuses and a pair of corresponding congruent legs. Okay, so with that in mind, we're going to move on to page 3, where we're going to do take a look at some other information. Page 2 has the proof of the hypotenuse leg theorem, and we're not going to go over that. You again can read it for your own information. And again, we're moving on to page 3. Okay, on page 3, we just have an important note about hypotenuse leg. When you mark the picture for hypotenuse leg, which again, I've duplicated the picture from page 1, the markings look like side-side angle, because of course we know all right angles are congruent. Actually though, that set of markings will only work in a right triangle because of Pythagorean theorem. If you recall, Pythagorean theorem says that leg squared plus leg squared equals hypotenuse squared in a right triangle. Therefore, if we lock in two sides, there is only one possible answer for the length of the third side. If that's the case, you're guaranteed that the third side of this triangle will equal the third side of this triangle. And if that's the case, your markings then become side angle side. And of course, we know side angle side works. Now, when your triangle is not a right triangle, like these two at the bottom, you'll see here we have a pair of sides that are congruent, a pair of angles that are congruent, and then we have a second pair of sides that are also congruent. Notice it's side-side angle. So you'll also notice these two triangles are not congruent to each other. So we have no guarantee that by knowing two sides and the non-included angle, I can't guarantee the triangles are congruent, and therefore we can't use it on a regular basis for all triangles. Also at the bottom of page 3, you'll find the summary for the 5 ways to prove two triangles congruent. This is also a really important topic that you should pay attention to and study, because you definitely need to know these 5 ways to prove triangles congruent. Okay, we're moving on to page 4. We're going to look at an example there. Okay, here on page 3, we have a proof that we're being asked to prove this triangle is congruent to this triangle over here. And as you can see, I've already taken the givens. I've written them down in the proof. Now, what we're going to do, of course, is, you know it, mark the picture. So, to show that DE is perpendicular to AC, I'm going to go ahead and make a right angle marker Also, BF is perpendicular to AC, so I'm going to go ahead and add a right angle marker to that. Also take note, because both of these segments are perpendicular to the same line, they would be parallel. That might be something you also want to use. So the other givens are that AD is equal to BC and that AE is equal to FC. And if you take a look, the markings on the picture very much look like hypotenuse and leg. So the next step in my proof would be to follow this given. So because of the perpendicular, you went ahead and made this mark, so we need to say that angle DEA and angle BFC are right angles. And we know this by the definition of perpendicular lines. Now, if those are right angles, then that means that triangle DEA and triangle BFC are right triangles. And your reason for that will be definition of a right triangle, which is that it has one right angle inside of it. Now, if you recall, back on page 1, I believe, we said that one of the things we needed to show that, to use hypotenuse leg, is we'd have to show the triangles are right triangles. So we just did that. As far as the congruent hypotenuse, well, that was AD and BC, congruent pair of legs, that was AE and FC, and we're pretty much close to being done. So we're going to go ahead and say those two triangles must be congruent to each other because of hypotenuse leg theorem. And that is it for this proof. We're going to stop here. I recommend that you try to get started on the second proof on page 5. I'm going to go ahead and slide that in here right now. Do keep in mind that to do this proof, you are going to end up having to use some segment addition to prove that AC is congruent to DF. Okay, so keep that in mind, and good luck working on that proof. We are now going to move on to the next section. Thanks.